Right. So we will finish up module 8 today. That participation quiz we'll look at later, so that should show up now. I will be using, in fact, let me just add it here so you don't have to hunt and find it. I added up the, I put post, but I'll change the name. So it's the complete version of the slides. That's kind of what we'll use here today. So let me just make this a little more obvious. So that's the ones I'll be kind of running through. You can use the skeleton slides, so you can kind of see I'll be drawing quite a few things to kind of add in there here today. Only thing left we have kind of this week, I'll put up the module 9 materials after class today. That module 9 reading is already up there. That's due before we start class tomorrow. All of the module 5, 6, and the 7 quiz and those participation quizzes from last week were all due last night. So the other things that'll be due this week is last Friday's participation quiz and then today's, and then the 2 participation quizzes from module 9, Tuesday and Wednesday. Those will all be due at the end of the day, Thursday, right? You'll also have a module 8 and 9 quiz pop up. That module 8 quiz will pop up today after I get back to my office. Excuse me, that will be due by the end of the day, Thursday. And then really quick turnaround on that module 9 because we finish it closer to the exam date. As soon as we finish module 9 on Wednesday, that quiz will be up there. You'll have 24 hours essentially, right, till the end of the day Thursday, a little more than 24 hours, I guess. But the end of the day Thursday to kind of get that module 9 quiz done. We will then do review on Thursday, and then we'll have that second midterm exam, which we already have the practice problems up there, on Friday, okay? So I had one person reach out to me. I still need to kind of get back to you. I didn't have a lot of time this morning to get through emails. I should this afternoon. But if that lockdown browser, if you had any issues with it, with that last or the first participation quiz from last week, you need to let me know because we're going to be using that same lockdown browser for that second exam, okay? So if you had any issues with that, please let me know as soon as possible. That means today, not, you know, Friday, the day of the exam, okay? All right. Other than that, any logistics questions for me? I think that should cover everything before we jump back into material. Let's see. All right. Okay. Let's make sure. I think you guys can hopefully hear me. Yeah, my audio. Just making sure that the audio was running. I always get paranoid about that. So we stopped at, we went through these examples. We stopped at thinking about indifference curves, okay? So I'm going to go through the traits or characteristics of indifference curves relatively quick so we save ourselves some time for other stuff. But we said, okay, we have this term of utility, which represents happiness or the benefit to consumers of consuming 2 different goods. We called it just X and Y. So it's all the different combinations of the 2 goods that would give us the exact same amount of happiness. So I think in like my example, you know, maybe this was, you know, a certain number of bags of chips and soda. So there was different combinations that could provide me with the highest amount of total utility, but there are amounts that could give me the exact same, right? So let's say we had, you know, the same price here. I could buy 1 bag of chips and, oh, I don't know, what, 3 here, so that would be 30. You know, there's different combinations of that. I could have 1 bag of chips and 3 sodas, and maybe that gives me the same total utility as having 2 sodas and 4 bags of chips, right? So different combinations that give me the same total utility, not the same marginal utility, but the same total utility. So the way that we're going to draw these in the graph is we have the quantity of 2 types of goods, right? This indifference curve is going to tell me that A and B would be different quantities of these 2 goods. So notice here I've got a little more pizza and less Pepsi. But these 2 combinations would give me the exact same amount of total utility, okay? So anywhere on that curve, the combination of those 2 goods is giving me the exact same amount of happiness or benefit. Now, we know that they're going to be downward sloping because if I want to keep total utility the same, well, we always know that marginal utility is positive. So if I start to buy a little bit more of this X good, more Pepsi, that's going to be adding to total utility. Well, in order to keep that number the same, I'm going to have to reduce the amount of pizza I have or lose some marginal utility from that other good. Okay? So we know they're always going to be downward sloping because we have positive margin utilities when we consume more of something. Okay. We also know that a higher indifference curve will always be preferred to a lower indifference curve. So kind of the reason why, if you think about like these three different points, it's a little bit difficult to see because like, okay, at point D, I've got more pizza, but less Pepsi. However, it must be, if I'm on a lower level of utility, the fact that I have more pizza, I must have liked Pepsi a little bit more. And then maybe another way of thinking about why, kind of solidifying why higher indifference curves, even though it's like, it's kind of tricky to see if we pick random points on those curves. Why do higher indifference curves always represent a higher amount of total utility? So let's say I've got this indifference curve, so indifference curve 1, and I've got a higher indifference curve 2. And these indifference curves should be parallel. I'll kind of always try to draw them parallel. We won't dive too much into that yet, but we should have these kind of parallel indifference curves. So think about if we were at point A. Why would there have to be, when we're on this higher indifference curve, right? Why does it represent more utility? So maybe we say, I don't know, this is 50 units of utility, however we're measuring that, right? 50, dollars worth of happiness, maybe. Well, if I think about being here on indifference curve 1, if I'm on a higher indifference curve, right, I would have the same amount of X, but more of good Y. So what has to be happening to my total utility? Remember, these indifference curves represent, if I can write total utility here. Well, if I have the same amount of one good, but more of the other, as long as the margin utilities are above 0, and we're assuming that, if I'm buying something, it's not going to have negative benefit to me, it has to have some positive benefit, then we know the value of utility on this higher indifference curve would have to be something greater. We've got the same amount of X, but more of good Y, I have to have a higher benefit. And you could think about it, you could go the other direction as well. Like maybe I want to compare this point to here. Well, I've got the same amount of good Y, but more of good X. This higher indifference curve has to represent a higher amount of total utility. Okay. So with this idea in mind, remember, this indifference curve now represents all the different combinations of these two goods that would give me the same amount of total utility. Okay. So the other trait we'll have is that these indifference curves cannot cross, right? So I said they're going to be parallel. That's the idea that they'll never cross, right? So why is that the case? Okay. If I think about, I can always, sometimes when I say things, you can always prove a rule by, it's some kind of logic. I forget what it's called, but like you prove a rule by showing that the falsehood can't be true. So let's say I had curves and they crossed. Okay. So here's my indifference curve 1 representing 50 units of utility. Here's my indifference curve 2 representing 100. Okay. Well, that makes sense over here, right? Because I've got the same amount of good X, but I've got more of good Y. So it would make sense that this indifference curve represents a higher amount of total utility. However, if they cross, then that means down here at these quantities, I've got the same amount of good X, but I've got a lower amount of good Y here. What would have to be true about this red indifference curve? Well, if I got the same amount of X, but less of Y, I must have lower total utility. So that doesn't make any sense, right? So if they ever cross, you would have two kind of regions, one that makes sense and one that wouldn't make any sense in terms of the directional change of total utility. If I have the same amount of one good but less of the other, I have to see that total utility goes down. That can't be the case here, right? If I'm thinking about this representing a higher amount of total utility. Okay. So we can't see these indifference curves cross. And so here, right, I kind of already worked through this example for us. It has to be that another way of thinking about this is if A and B are on the same indifference curve, they must be providing me the same amount of total utility. So let's say that was 50. If A and C are on the same indifference curve, they must be representing the same amount of total utility. Well, if this was 50, well, no, indifference curve 1 represented a total utility of 50. So indifference curve 4 here would have to represent some other amount, but we know that A is giving us 50. So it's just not possible, right? There's no way that A, B, and C, right, would all be representing the same amount of total utility because they're on different curves. And the whole point of this indifference curve is it's representing the different combinations of these two goods that provide the exact same amount of utility. So every different indifference curve is representing a different amount of total utility. Okay? So we can't see them cross. Okay. And then they're going to be bowed inward. So this is the idea. If I'm thinking about what the indifference curve is telling me, I'm jumping the gun a little bit here. It's how much of the Y good am I going to have to give up in order to keep total utility the same to get one more of the X-axis good. Okay. So maybe thinking about this in a slightly different way. If I had total utility of 100, and let's say the marginal utility of the last units of good X was, oh, I don't know, what I want to make a nice easy one here. Let's say they were all 10, right? And then let's say the marginal utility of the next unit of good X is 60. Well, if I buy one more unit of good X, what is my total utility now going to be? 100 plus 60, or 160. Well, remember, when we're on that same indifference curve, that's representing that when I buy one more unit of X, how much does that quantity of Y need to fall by in order for me to keep total utility the same? So if I add one more unit of good X and I now have total utility of 160, I need to lose total utility from good Y of 60. If every unit of good Y is giving me 10 additional units of utility, how many would I have to reduce this by? Right? 10 times 6 to get that same total utility of 100. So I'm going to have to give up 6 units of good Y to get one more unit of good X. Okay. Now, why is it bowed inward? Why isn't this kind of the linear line? Well, we know as I have more of good X, what's happening to its marginal utility? So if I go from, 1 to 2, if I then want to go from 2 to 3, that same 1 unit increase, what should be happening to that marginal utility? So maybe this was the marginal utility of the second unit of good X. The marginal utility of the third unit, we said there's diminishing marginal benefits. The more I have of something, the less and less additional benefit it provides me. So I know that that must be decreasing. So maybe it's something like 40. Now how many units of good Y would I have to give up? Well, if the marginal utility of Y stayed the same, it would be 4, a smaller amount. But remember, when I gave up 6 units of good Y, what was actually happening to the marginal utility? It was going up, right? So now it might even be, I don't have to give up 4, I might only have to give up 2 or 3 units of good Y. Okay? So the idea that as I have more of something, the additional utility I'm getting is going to be lower, so I'm not going to have to give up as many units of the other good, right, in order to kind of keep total utility the same. So in kind of my example here, initially, to get one more unit of good X, I had to give up 6 units of good Y, or one more can of Pepsi with 6 slices of pizza. But once I start to have more cans of Pepsi, it provides me with a smaller benefit. I'm willing to give up fewer and fewer slices of pizza, right? All right, so I'd go through those kind of quick. Any questions over anything I said there, or wanted to see something reviewed before we keep moving? So this idea that we are going to be willing to give up less and less of that Y-axis good to get one more unit of X, essentially that's telling us, well, what would the change in Y be? Change in the quantity of Y over the change in the quantity. That's our slope. So the slope of our indifference curve is becoming flatter and flatter, or representing that to get one more unit of the X-axis good, I'm willing to give up less and less of that X-axis good. So we're going to call this slope our marginal rate of substitution. So just like with our income constraint, the slope told us if I wanted to buy one more unit of good X, how much of Y would I have to give up in order to be able to afford it? Well, it's kind of similar. It's just now instead of income being our constraint, with our indifference curve, total utility is what we're trying to keep the same. So that's kind of our constraint. So now the slope of our indifference curve represents if I want one more of this x-axis good, the slope tells me how much of the y-axis good I'd have to give up to keep total utility the same. Not how much I can afford anymore. That was the income constraint. The indifference curve is telling me how much of that y-axis good I have to give up to get one more unit of the x-axis good in order to keep total utility the same. And that amount is decreasing as I have more and more of that x good, because as I have more and more of that x good, it provides me with less additional utility. Okay. So what ends up being true is that marginal rate of substitution is just going to be the relative size of the marginal utility of good x compared to the marginal utility of good y. And you can kind of think about in my earlier example, that's really what we were doing here. When I wanted to get one more unit of good x and it was 60, and the marginal utility of good y was 10, to get one more unit of good x, how many units of good y did I have to give up? I could really think about what was I doing, taking 60 over 10, or I was taking the marginal utility of the x-axis good, dividing it by the marginal utility of the y-axis good. Okay. So that's kind of representing our trade-off in order to keep total utility the same between these two goods. Okay. All right. So why does this kind of have to be true? Because we're trying to keep total utility the same while remaining on the same indifference curve. So if I'm gaining some additional utility from x, I have to be giving some up from good y. How much I'm going to have to give up, we just kind of look, with some numbers, I think it kind of makes sense. Well, however much I'm gaining from good x, dividing that by however much I'm losing from good y, that tells me how many units of good y I'd have to lose or give up. Okay. Excuse me. So this shouldn't be difficult, right? If you see problems like this on the quiz or on the exam, if we want to calculate marginal utilities, really all they're representing is, in a way, we kind of can get that from quantities as well. So here I don't have the marginal utilities, but I can still find my marginal rate of substitution. And that's because I can find the slope of this indifference curve. I could use marginal utilities, but I also know this marginal rate of substitution represents the slope of my indifference curve, which if I have the quantities, I could use those as well. Okay. So notice I move from point A to point B. How would I find the slope? Well, it's the change in y over the change in x. So once again, this is going to look kind of similar to the budget constraint, whereas if we're using quantities, it's typically how we think about finding the slope, right? Y over x. Right? So in order to get one more unit of good x, I have to give up 2 units of good y. So my marginal rate of substitution here would be 2 over 1, or, right, it doesn't matter which direction I move. If I move from A to B, it's going to be going down by 2 and up by 1. So negative 2 over 1 or negative 2. Okay. Now, as I have more of x, what should be happening to that marginal rate of substitution? In order to kind of get one more unit, I'm willing to give up less of the other good. So I could think about if I'm moving from point C to point D, well, now, in order to get not just 1 unit, but in order to get 4 additional units here of good x, right, I'm only willing to give up 1 unit of good y. So how much is each unit costing me? Essentially like a fourth of a unit. Or if I take that change in y of 1 over the change in x, negative 4, I'd have negative 1/4. Okay. So what is happening to my slope? Before it was negative 2, now it's negative 1/4. As I have more of that x-axis good, the slope is getting flatter and flatter, or I'm willing to give up now only a fourth of a unit of good y, whereas before I was willing to give up 2 units, right? I'm not willing to give up as much. Okay. So when we're using quantities, it's y over x, right? The change in the quantity of y over the change in the quantity of x to calculate that slope. And here, I'll kind of write something out before we combine these two things. So just like with, so when I had my indifference curve, we had the same thing on the axes, right? So if I think about going back to last class, for an indifference curve, we can find the slope by taking the change in the quantity of y over the change in the quantity of x. And we proved here, because like the intercepts were m over the price of x and m over the price of y, we showed that this is actually going to always be like a negative value since it's downward sloping. But this will be the same as the relative price of good x to the price of good y. Okay. That'll also be true about our indifference curve here. Okay. We can find the slope by taking the change in the quantity of the y good over the change in the quantity of the x good. It's downward sloping, so it'll always be negative. That's going to end up being the same as the margin utility of good x over the margin utility of good y. Okay. Any questions there? So it kind of flips. If we're using prices or marginal utilities, x is in the numerator. If we're simply using quantities, because that's the visual of the graph, then the slope, it's just the whatever's on the x and y axis. Okay. All right. So if both of these things had quantity of x and quantity of y on the same axis, we can put them on the same graph. So ultimately, we're going to take what we now know about these indifference curves and our budget constraint. And the goal is going to be, well, what does a consumer want to do? They want to get to the highest level of total utility. We walked through those examples last class where we showed you can use the margin utilities per dollar in order to kind of bounce back and forth in between the two goods. But there's a quicker way we can kind of do this and see this in a more continuous environment. And so really, we're going to try to get to that highest possible total utility or the highest possible indifference curve while being constrained by our budget, right? Obviously, we would like to get to the highest possible indifference curve, but we only have so much money, okay? So what is that going to look like? So I've kind of got something drawn here. It's kind of a summary of it, but I'll kind of build this out for us. I think maybe be able to see it a little bit easier, okay? So let's say I've got any two goods, and I've got, here's indifference curve 1, here's indifference curve 2, here's indifference curve 3. They all represent, I don't know, higher levels of total utility. They don't cross, right? Higher indifference curves or points further away from that zero, that origin, represent higher amounts of total utility. I would love to be up here on this indifference curve. Let's say there are these, for the sake of this example, these are the only three indifference curves. The problem is, if my income constraint is right here, well, these are the combinations of goods X and Y I can afford. In fact, there might only be one point on this indifference curve I can actually afford. These points would actually be above my income constraint. So this point would be unaffordable, right? I would love to be up here, but these points are even more unaffordable, right? So what would have to happen? Well, in order to be able to enjoy this amount of total utility, what would have to be true about my income constraint? These points that are unaffordable now have to become affordable. So what would I need to see? Something like an increase in income. Now we can't afford these points, but we can afford this one point. So given our budget constraint, right, we're going to get to that highest possible indifference curve. And let's say there was an indifference curve like here. If we have more income, why would we choose this point? It's going to represent a lower amount, call this 4, of total utility when I can afford to get to an even higher one. So we're really going to look for what indifference curve, the highest indifference curve we can get to, given whatever our budget constraint is. Okay. And then as we have more income, right, we can afford to get to higher and higher levels of total utility. I think that's somewhat intuitive. The more money you have, live in a nicer house, have a nicer car, etc., right? Buy more things. Okay. So that's kind of what that would look like, right? So notice these 2 points are both points I could afford, but why would I buy here when I'm on a lower indifference curve if I could afford this point and it would put me on a higher indifference? I'm spending the same amount of money, but if I'm at 4 cans of Pepsi and 3 slices of pizza, I have a higher amount of total utility than if I'm at 2 cans of Pepsi and 4 slices of pizza. Okay. So that's the kind of general idea of this consumer optimum. Okay. what'll also end up being true, and I try to draw this, but at that optimal point, the marginal rate of substitution will end up being the exact same as the relative prices. So the slope of our income constraint or our budget constraint was the relative price of good X to good Y. The slope of our indifference curve was the margin utility of X to the margin utility of good Y. Okay. If that's true, if I rearrange this a little bit, I basically have the margin utility per dollar or divided by the price is the same for both goods when we're at this point where the slope of the budget constraint is the same as the slope of the indifference curve. So we said, we walked through this a little bit more last class, why this will hold. And that's really a visual representation of margin utilities per dollar being the same for both goods, is that point where the slope of my budget constraint is the same as the slope of the indifference curve. That would mean this is true, rearrange. It's really just saying the margin utility per dollar is the same for both goods. Okay. So before we get to things that change that budget constraint, I'll try to give you a little bit more support as to why that point, why we see the margin utility per dollar be the same. So let's say I've got a budget constraint. Here's my indifference curve. Got two goods. Okay. So I'm telling you this point is where the margin utility per dollar is the same for both goods. Okay. Well, what must be true? So let's say I was here. Right? If this was the current quantity of X and Y I was buying, what do I notice? The slope of my indifference curve is the margin utility of X over the margin utility of good Y. Now they're both negative, so I'm just going to take the absolute value to make it easier to talk about the relative size of these things. So notice what's true about the slope of my indifference curve relative to the slope of my budget constraint, which the slope of our budget constraint is the price of X over the price of Y. If it's steeper than an absolute value, that slope of the indifference curve is greater. Okay. So if I rearrange this a little bit, right, divide both sides by the margin utility of good X, multiply both sides by the price of good Y, right? Actually, no, I want to do this the other way, make this easier. So if I, multiply both sides by the margin utility of good Y, oh, here, I'll leave myself enough room. Well, I can do it up here. So I've got margin utility of good X over the margin utility of good Y. We said it's steeper, so this is greater than the slope of the budget constraint. So if I multiply both sides by the margin utility of good Y, this cancels. I then divide both sides by the price of good X. What I'm really left with here is that at that point, the margin utility per dollar of good X is greater than the margin utility per dollar of good Y. So if I'm at this point, what should I do? I should buy more of whatever has the higher margin utility per dollar. So I'll keep buying more of good X. Notice the slope is still steeper. So it's still, this range would represent the margin utility of good X per dollar spent is greater than the margin utility per dollar of good Y. So I keep buying more X. Now, if I were to go past that point, let's say I was somewhere down here. Well, now the slope of my budget constraint is flatter. So the margin utility of X over the margin utility of Y, that's the slope of my budget constraint. Right? That is flatter, so it's going to be a lower value than the slope of my, the slope of my indifference curve is going to be a lower value than the slope of my budget constraint because it's a little bit flatter. If I rearrange this a little bit, kind of same idea, multiply both sides by the margin utility of Y, divide both sides by the price. What this is really saying is the margin utility per dollar of good X is less than the margin utility per dollar of good Y in this range. So what should I do more of? Buy more of good Y, less of good X. So in these areas, it represents where the margin utilities per dollar aren't the same, and people will change their spending habits until we get to this point where that margin utility per dollar of both goods, the slope, is going to be exactly the same. So we would have the margin utility per dollar spent is the exact same for both goods at this point. Now there's no incentive to buy more or less of good X, and we would kind of stop there. Okay. So I'm not going to make you kind of probably walk, through all this, but we are using, I might make you use this idea that we know at that consumer optimum, the marginal rate of substitution should be equal to our relative prices. So if we're not at that point, we can put like a directional sign to it, and then we know which good is going to have a higher margin utility per dollar. We should buy more of that good. Okay. All right. Any questions before we continue here? All right. So with this in mind, we've got a very, I shouldn't say very, I have a more simplistic example than what we'll eventually kind of walk through. But let's say, I kind of already drew in there earlier, thinking about like income changes. But let's say we had a change in the price of a good. What is that going to do? Well, under this scenario, so I can kind of think about, let's say the initial prices, I had pizza and Pepsi here. The highest possible difference curve I could get to was this point of 3 slices of pizza, 4 cans of Pepsi. If the price of Pepsi goes up, right, goes from $1 to $2, what's going to happen? Well, no change in how much pizza I can afford to buy, right? We said our budget constraint will stay the same intercept at the value that, or for the good that doesn't have a price change. However, the good that had a price change, we're going to see a decrease in how much we can buy if we were only buying that good. So notice what has happened to the slope of our budget constraint, right? Well, it's gotten steeper. Also, this point of 4.3, we can no longer afford to get to. It is now above our new budget constraint, so we can't get to the same level of total utility that we could before. Right? In fact, now, facing our new budget constraint, we might continue to buy the same amount of pizza, but because we don't have as much money, because our income can't buy as much Pepsi since it's twice as expensive, we might see the amount of Pepsi purchased fall, right? Price doubled, we buy half as much as we were before. Okay. So whatever good we see this price decrease in, right, we're going to see a shift in our budget constraint along that axis, and it's going to lead us to only being able to afford to get to lower levels of total utility. Okay. Kind of think about it this way. Essentially, what is this saying? This is the idea of inflation. If I have the same amount of income, but prices are higher, I can afford to buy less than I was before. I'm not going to be as happy. I can't buy as many things as I was previously. Okay. So I've got some kind of blank slides here. I'm going to go through some other changes in price. I'm also going to go through some changes in income. I'll do the income one first, just because I think might be a little bit easier. So I kind of already showed you an example of this one, so I'll probably go through it pretty quick. But let's say my income was here, and here's the indifference curve that I was on, right? Here's my kind of optimal point. So maybe initially got this amount of good X and this amount of good Y, okay? If I see, and I kind of did an increase in income earlier, so let's say we saw a decrease in income. Okay? So if I had a decrease in income, that's a parallel shift. Remember, there it is. We're saying the slope of this indifference curve is the margin utility of good X over the margin utility of good Y. And at that consumer optimum, that'll be the same as our relative prices, or the slope of our, not here, sorry, budget constraint, right? BC, not IC. So if our budget constraint now with this lower amount of income, so this was like a income decrease, we're actually going to see the indifference curve I can afford to get to. Try to draw these parallel here. So now I've got my second indifference curve. Maybe this represents, only utility of 50. Well, now my consumer optimum, when I have less income, might be that I actually can afford to buy less of both goods, right? Now, the relative price and the marginal rate of substitution at this point, it's actually the same, right? The slope is the same. So the margin utility per dollar of both goods hasn't changed, but because we have less income, I can't afford to buy as much of both goods, okay? So we would kind of see from these income changes, we would simply see a reduction in how much we can afford to buy of both goods, because there's no change, right, in the relative prices. It's just that we've got less money to spend. Okay. Any questions on this before we keep moving here? So I think in the slides, most of it, it's drawing changes in price on the x-axis, which is fine. And if you're drawing it yourself, you always can kind of choose what you want on the x-axis. But if you're given a depiction and it kind of dictates what's on the x and y axis for you, what did we do before? We did a price decrease. So let's do, or we did a price increase. So let's do here. Let's say this is our original budget constraint. Right? And initially, this was the highest indifference curve we could get to. I'm just putting numbers to it, thinking about like total utility just to make it a little bit easier. And now I'm thinking about where did I start out? How much of X and Y was I buying? If I see a price, let's say, decrease in good Y, what's that going to look like? Well, I probably should have drawn my Y-axis a little bit higher here, because we know that if the price of Y goes down, facing my same income, I could buy the same amount of good X if that's all I was buying. But if using all of my income, I'm now buying only good Y, I can afford to buy a higher amount. Right? Now, what should that do to my slope? Right? The slope of my budget constraint, so here's kind of like my second budget constraint, it's going to be a little bit steeper. Or if I think about the margin utility, if the margin utility per dollar should be the same here. So before, we had the margin utility per dollar was equal for both goods at this initial point. What happens when the price of Y goes down? The relative price, I'm dividing by a smaller number, would actually go up. So what should I do more of from this point? Well, I should actually buy more of good Y and less of good X. Right? So what do we see if we try to draw in these parallel indifference curves? Well, intuitively, if prices are lower, it's almost like I have more money, so I should be able to afford more things and get to a higher level of total utility. So kind of notice here, where is my new optimum? Where does my new budget constraint hit this higher indifference curve that I can get to? And what do I see? Oh, I bought less of good X and more of good Y to get to that new optimum. And that's essentially because when I see this price decrease, the margin utility per dollar of good Y is now higher. That means I should want to buy more of it. Okay? So you could have a change in the price of good Y, a change in the price of good X. It could be an increase or a decrease. That's just going to kind of shift, right, one of your intercept points. And then if you have lower prices, you should be able to get to higher indifference curves. Okay? When you have higher prices, like we had in the example in the slides, higher prices resulted in us being on a lower indifference curve. We're having lower or less total utility. Okay. All right. So any questions over anything there? Because we're going to complicate this even a little bit more. Okay. Where are we at in time? All right. We're doing pretty good. So what I just drew out for you was what we would call the total effect of a price change. Okay? So the total effect of a price change, we can see in our other previous example, I had what? Quantity of Y went up and the quantity of X went down. But we can actually break that down into two different types of effects. Okay. So think about it this way. If the price of X here, and I think, we're back to our other example, if the price of X goes up, right? Well, now the margin utility per dollar is lower. It's going to be less attractive, right? We're not going to want as much of good X as we were before. We want to buy more of good Y. So the fact that we have this price change, right? It's going to change the slope of our indifference curve, and we're going to want to substitute towards whatever is now relatively cheaper and away from what is now relatively more expensive. So this substitution effect is whatever good has a price increase, I'll buy less of that, more of the other good. Now, the real income effect is going to be that when prices are higher, what's happened to the value of my income? Well, if prices are higher, the real value of my income, like let's say I was only buying good X and the price is higher, how much can I afford to buy? Less than I was before. So when prices go up, it's also going to have this income effect, which is that it decreases my real income. And now, because of a decrease in income, if these are both normal goods, what would I do for both? Buy less of them, right? So it's not the income effect that we talked about in previous modules isn't really your like dollar a salary that you see on your pay stub. It's actually how much that amount of money can buy, or your real income. So when real income goes down for normal goods, we buy less of them. And we'll talk about what inferior goods might look like here in a second. So I've got one here. I'll kind of use the slides and then I'll give you another example. But let's say I had the price of soda and pizza again. So starts out soda's $4, pizza's $1. The price of soda falls, so we have a price decrease. What's going to happen? So our old consumer optimum, the point where that indifference curve hit our budget constraint, was right here at 600 slices of pizza and 150 sodas. If the price of soda goes down, if we're only buying soda, this intercept should move up, right? So we can identify kind of where the new consumer optimum would be. This would be what we call our total effect. Okay. Excuse me. So the total effect of this price decrease is that I see that I buy less pizza and more sodas. Right? But we can actually break this down into two different ranges. Okay. So let's say we had that same price decrease. Okay. The substitution effect is going to be, all right, given this new price, which we know would shift out our budget constraint, if we were to stay on the same amount of total utility, right? So this price decrease, if we want to face the new relative prices, but we're assuming that we stay on the same amount of total utility, right? Where would the slope of my new budget constraint hit that total utility, right? Well, if prices go down, we know that the marginal rate of substitution, or if prices go down, that relative price would be lower. It's equal to the marginal rate of substitution, which is the slope of the indifference curve. It should be a little bit flatter. So moving from point A to B is going from facing my old relative prices and how much utility I could afford to if I stayed on the same level of total utility, but I faced the new prices or that new slope, that movement is going to represent our substitution effect. Okay. So whenever the price of a good goes down, we're going to be looking for a flatter point in that curve. So that's going to tell us, oh yeah, when the price of the X good soda went down, we should want to substitute towards that good and away from the good that didn't experience a price change. Okay. Oops. Any questions on that? And I'll draw this out in a slightly different way on the slides here in a second. Or on the slides, on the dot cam. Now, the income effect is going to say, okay, look, yes, this is my new relative price, but I know that because when prices go down, I have more income. I can afford to buy, areas in this range. I can afford to buy bundles that I no longer, or I previously wasn't able to afford. So instead of just thinking about, okay, I face the new relative prices, but if I didn't keep total utility the same, where would I be at, or what indifference curve facing these new relative prices can I now afford to get to? So the movement from point B to point C, we've kept relative prices the same, so there should be no substitution effect. However, we know that we can now afford, because real income is our income divided by prices. If prices are lower, real income goes up. We can now afford to buy more of both goods. So notice movements from point B to point C, that's our income effect. There we actually see the income effect is I buy more of both goods. Now, what's the total effect? Moving from point A to point C, we don't typically always see this. These are A and C are what we see when we're looking at the actual data. Point B here is kind of this hypothetical point that allows us to break down the total effect moving from point A to point C, where we bought less pizza, more soda. We can see that, okay, part of that movement, right, was coming from a substitution effect. I was buying more of whatever is relatively cheaper. And then part of that movement was coming from the income effect. The fact that my same amount of dollars in my pocket has more value, I can buy more of both goods. So notice, because of that income effect, the reduction in the quantity of pizza or the Y good isn't near as large as what that substitution effect was. Okay. Any questions on that before we keep moving? So I'll draw out another example. Just I think seeing more of these is probably going to be helpful. So let's say I had a good, and we just did a price decrease. So I want to do a price increase. So let's start out. Here's our first budget constraint. Here's our first indifference curve. And kind of think about this is going to be kind of point A. Okay. So initially we were kind of here. This is our quantity of the Y good, quantity of the X good. Okay. If I see the price of, I'll shorthand this here. So I want to do the price of Y now. Let's say it goes up. Okay. So I'm just going to think through this before I even draw the visual, or at least start it. I can think about, what is my real income? My real income is just taking the income and dividing it by prices. So if the price of Y goes up, what's happening to my real income? Denominator is larger. My real income would be going down. Okay. So I can initially think about, if these were both normal goods, what should that income effect be? Well, if I have less real income, I should see the quantity of both X and Y go down. Okay. Now, before I even think about it visually, if I have a substitution effect, well, if the price of Y is higher, what should I do? Buy less of good Y and buy more of good X. Okay. Now, this is where it gets tricky, because what's the total effect? Well, I know that when prices of Y goes up, I should see the quantity of Y go down, but I actually don't know, unless you tell me something about the relative size of the income and substitution effects. I actually don't know what's going to happen to the quantity of good X that I buy. So now I'll kind of try to draw this, we can reason through it using shorthand, but what is the visual going to look like? Well, if the price of Y is higher, what's going to happen? If I'm only buying Y, I can buy less of it. I should bring a ruler for things like this. So here I've seen a decrease in my budget constraint. Okay. For this new budget constraint, I can think about, all right, what if I created the hypothetical? I need blue. There we go. So facing these new relative prices, let's assume I didn't have a change in real income. So I could afford to buy the same amount of total utility as I was before. So I'm going to draw in kind of a parallel line here, which is representing I can afford to buy the same amount of utility I was before. However, I'm facing the new relative prices. So this kind of dashed, try to draw in a little bit more here, blue line, you could almost think about this as like a hypothetical budget constraint. So if I move from point A to point B here, A to B is going to represent, well, I've kept total utility that I can afford the same. I've shut down the income effect. However, I'm looking at my new relative prices, or I'm allowing the slope of my budget constraint to change. So this should represent my substitution effect. So if I think about this hypothetical quantity, what do I see? Oh, the quantity of Y went down, quantity of X went up. That lines up with what we were thinking about for just intuitively a substitution effect. Okay. Now, if I'm thinking about, okay, where is the new indifference curve I can get to? So I want here, I want to have decrease. So I want to get, oh, let me see. I'm going to try to draw these parallel here. So let's say this is going to be the new highest indifference curve I can get to. Maybe it's only, I don't know, total utility of 80 instead of 100. Well, now at point C, right, this is going to represent the total, right, change, like where I end up after that price change. So movement from point A to point C represents my total effect, but movement from point B to C is saying, okay, look, if I were to keep relative prices the same, so if I'm keeping relative prices the same, I'm shutting down the substitution effect. So the movement from point B to C is saying, shutting down that substitution effect, keep the relative prices the same, but I know that because the price is higher, my real income decreases. What is that income effect? Well, moving from point B to point C here, if that's my income effect, what's happened to my quantity? Well, going from that hypothetical like midpoint to the final result, I see that the quantity of X goes down, but I also see that the quantity of Y has went down, right? We must have had normal goods. We had real income go down, and as a result, the income effect was I bought less of both, okay? Now, what is the movement from A to C? Well, that's the combination of both of these effects, or that would be my total effect. So the way that I drew this here, it looks like my total effect is that I bought what? Less Y and more of good X. So here, I would have to know that what is true. If the total effect is I bought more of good X, the substitution effect from that price change must have been larger than the income effect for good X. Now, if I had this drawn out differently, we can see that sometimes, going back to the one I had here, the initial example, sometimes price changes, the total effect can be you buy the exact same amount of the good that didn't experience the price change. And that's because the income and substitution effect will be going in opposite directions. If these were the exact same size, what would the change in X be? Nothing. It would stay the same. Right? So without any additional information, we really don't know the total effect on the good that doesn't experience that price change. Okay? Any questions on that before we keep moving here? So that one was here. We stopped. Okay. So I moved things around a little bit for the sake of time here. So I'm gonna, well, I'm gonna come back. I've got some stuff at the end. Just want to kind of show you. Oops. So these slides I might come back to at the end of class if we have time. If not, I'll start tomorrow with them. But I know that there's some things on the quiz that I want to make sure we get through today. So we're going to skip ahead. We're going to think about these income and substitution effects. They might be of different size. And really, where does that come from? It comes from the fact that some goods are complements, some goods are strong substitutes, some goods are weak substitutes. So we'll kind of dive into the extremes of this to kind of prove this if we have time at the end of class. Excuse me, but I want to focus more on, and I've got another, I drew one for you out of the slides. Here's just another example if you're wanting something else to kind of visualize this. So you can think about here, if I start off, and I had, where is that? So here I've got the initial budget constraint right here. If I go to this higher budget constraint, what must have happened? Well, the price of movies. If I can buy more movies now with the same amount of income, it must be that the price of movies went down. So it's basically what we just worked through, but on the x-axis and a price decrease. Or sorry, yeah, price decrease. Okay. So if I have a price decrease, just to kind of replicate all of this, we actually don't need that graph. I'll show you what the points in the graph that represent this, but you can use shorthand to understand this. Right? So if I have, what were the two goods? Movies and, no, I forgot. I'm trying to, movies, and soda. I was really on a soda kick, I guess. So I've got the price of soda, price of movies, and I had whatever my initial income was. Okay. Well, if the price of movies goes down, right, I can think about what's going to be my substitution income effect. So when prices go down, what's happening to my real income? Well, my real income is just income divided by prices. So if prices go down, we said real income goes up. So my income effect for both goods, if they were normal goods, would be I buy more soda and I buy more movies. However, the substitution effect says if something is relatively cheaper, I'm going to buy more of that and less of the other good. So what is my total effect? Well, I know that I'll buy more movies. I don't know what's going to happen without any more information about the size of the effects to the quantity of soda that I buy. Okay. Now, if I give you a depiction, you don't have to say and determine it, because we can think about, all right, moving from this initial budget constraint where the highest indifference curve I could get to was 1, I1, I was at point C. The total effect is going to be moving from C to J, this new budget constraint, the highest indifference curve I can get to. So there I see the total effect is I actually bought less less soda and more movies. So I know the total effect for soda is actually I buy less. So the substitution effect should be larger. So if I'm looking at my graph, what tells me the substitution effect? Well, that is if I stayed on the same indifference curve, but I faced these new relative prices. So what point on the old indifference curve would I see this new relative price or new marginal rate of substitution on the old indifference curve? Looks like it's down here at K. So the substitution effect is I bought what? 4 fewer sodas, and I bought 2 additional movies. What is, so here we just put some numbers here. So I said what? The substitution effect was I bought 4 fewer sodas, 2 more movies, right? So I'm just writing these down here. The income effect was if I kept the relative prices the same, where would I be at on the old utility, total utility curve or indifference curve, compared to the new higher total utility or indifference curve I can get to? Well, that movement, keeping relative prices the same, I've shut down the substitution effect. There, the income effect is I buy 1 more soda and 2 more movies. Right? So I bought 1 more soda, 2 more movies, must be normal goods. So what should the total effect be? I bought 3 fewer sodas, 4 more movies. Sure enough, if I look at that graph, what was the total effect going from C to J? I bought what? Wait, did I do my math wrong here? 1 and, oh yeah, because no one called me on that. Going from C to K, 6 to 3 is not 4. 6 to 3 is losing by 3. So we should see 2 fewer sodas, right? So sure enough, going from the total effect C to J, I buy 2 fewer sodas, but I went from 2 to 6, I bought 4 more movies. Okay. So we can decompose these total effects into substitution and income effects. Okay. But then we have one additional kind of issue, right? Which is that what if they're inferior goods? Okay. So I've got kind of some setups here. We've really only went through examples where we had normal goods here, so that income effect was positive for both. If we had inferior goods, potentially that real income effect could be that it decreased. If I have more income, it would decrease the quantity I buy of inferior goods. Okay. And then if we ever ended up with a scenario where that income effect was greater than the substitution, we can end up with these things we call Giffen goods. Okay. So I'll walk through some shorthand here. We got 15 minutes. I want to make sure I save some time. So I think we can get through this. Before we look at a visual, I'll do the shorthand. So this was kind of like our 2 normal goods. Notice when real income went up, quantities both went up. So this was the idea, the example where we had 2 normal goods. And that's really the only examples I've shown you up to this point. If we had an inferior good, so let's say I can buy 1 normal good, 1 inferior good. Right? let's say X is normal and Y is the inferior good, okay? If the price of X goes down, what's going to happen? Well, first of all, before we even think about the income effect, what do I know the substitution effect? Doesn't matter if it's a normal or inferior good. I'm going to buy more of whatever is relatively cheaper, less of whatever is relatively more expensive. So I now have my total and income effect I want to dive into. So to know the income effect, what impact would this have on my real income? Once again, real income is just income over prices. So if prices go down, my real income goes up. If it's a normal good, that means I'm going to buy more of it. If it's an inferior good, that actually means I'm going to buy less of it. Right? So here, because price changes can increase real income, here I've got a scenario where I know that when this price change occurs, I'm definitely going to buy more of X, and I'm definitely going to buy less of good Y. So in some of these scenarios, it becomes easier to think about what's going to happen with the total effect. Okay. Now let's flip this and think about instead, I've got X was my inferior good and Y is my normal good. This gets a little bit more interesting. So let's say I have that same decrease in the price of good X. So we said that's going to do what to my real income? Increase it. So I'm thinking about that substitution effect. We said people would buy more of X, less of good Y. But for the income effect, if my real income goes up, what happens for inferior goods? I actually buy less of them. And what happens to normal goods? I actually buy more. Okay. So we can actually have this really weird scenario. So if I don't know the size of these shifts, I don't know what's going to happen to for the total effect of the quantity of these two goods. Well, notice, what if that income effect is greater than the substitution effect for good X? What would the total effect be? Well, the income effect would cancel out the substitution. We would actually see that the quantity goes down. So I had a price decrease and people actually bought less of this good. How does this happen, right? So we would call this a Giffen good. When the price of a good goes down and as a result, people actually buy less of it, or flip side, if the price goes up and people actually buy more, it must be a good such that the income effect that it's having, right? Like people might be spending like a really large portion of their income on it, but if it's an inferior good, when the price goes down, I'm going to buy a lot less of it, right? It was a severe, I was only buying it out of necessity. So now if I have more real income, I'm going to really kind of stop buying this inferior product, maybe ramen noodles, and buy, better food, right? So if you ever have the income effect be greater than the substitution effect, right, then we have what we call this third category, which is a Giffen good, okay? So what does this look like visually? These are hard to draw out. So I drew one ahead of time to make sure that I wasn't, needing a ruler and everything, making sure my lines are parallel. So here, if I had this initial thing, I use the example of what? Some really cheap whiskey, and then there's a great distillery in Indianapolis called Hotel Tango, one of my favorites. Maybe when you're 21, go visit. But if we had a price decrease in this inferior product, right? So I can now buy more of it if I was using all of my income. Well, I think about the total effect here is maybe that I go from A to C. So this price kind of decrease, I actually bought a little bit less of it here. Or sorry, I bought more of it. I could think about, well, the only way this is truly a Giffen good is if that total effect is I bought from a price decrease, I actually bought less of it. So this wouldn't be a Giffen good, right? Because our total effect, we can see that price and quantity don't move in the same direction. But we could kind of break this down to see what happens with inferior products. So if I want to look at my new relative prices, but say on the same indifference curve, when I saw a price decrease, I bought more of that good, less of the other. So my substitution effect, facing new relative prices, keeping total utility the same, looks pretty consistent. But notice, oops, here moving from B to C, that would represent my income effect, right? Keeping relative prices the same, but I can now, with this lower price, afford to get to a higher indifference curve. So moving from B to C, I saw like a small reduction in how much I was buying of the cheap whiskey, and that must be because it's an inferior product. Yes, my real income went up, but it must be that I had, if I bought less of it as the income effect, it must have been an inferior good. Right? Now, in this example, my income effect must not have been as large as the substitution effect because that total effect moving from point A to point C was positive. So the only way I would have a Giffen good, is if total effect, and here I shouldn't have these crossing, but just to kind of give you an example, it would have to be like somewhere down here where the total effect is I actually buy less of that good. And the only way that's true is if that income effect is greater than the substitution effect. Okay. So with these Giffen good examples, I'm less likely to give you something like this visual, a lot more likely to, and I already moved it to the back, have you rely on kind of this shorthand, okay? And just the idea of what an inferior good is and what that would make the income effect, okay? All right, so income substitution effects. We've now talked about this possibility of a Giffen good. I've got some stuff here deriving the demand curve. If we got a little bit of time here, we'll come back to this stuff. But I want to make sure we have enough time to just at least go through these questions on the practice quiz. There's only 2 of them, so we should be able to do this pretty quick. I think it would be nice to have the time to go through those perfect substitutes complements. So let's say I had an example, like question 1. And I'm thinking about which of the following statements is true. So this is just going to be hammering home some of the characteristics we talked about with these utility curves. Okay. In fact, I'll go here to make sure we can answer these together. Also, when you take them, it shifts the answer. So even though it's my first answer, it shuffles these, right? So I and J are affordable. So if this is my current budget constraint, I can afford any point on that curve. So I could afford point G, I, and K. However, I can't afford points above that, so I could not afford point J. J is unaffordable. But I is right on this indifference curve, or sorry, on my budget constraint, so I can afford point I. So that one's true, or sorry, that one can't be true, right? I can afford I, but not J, so they're not both unaffordable. G provides a higher level of utility than point J. Well, G is on a lower indifference curve than point J, so that actually represents a lower amount of total utility, so that one can't be true. H and K is using all of our income. Well, once again, we said the only points where I'm spending all of my income are on the budget constraint, so that would be G, I, and K. H, I'm actually not spending all of my resources, so that one's not true. H and G provide the same amount of total utility. So G is I'm spending all of my income. H is I'm being inefficient. But because they're on the same indifference curve, they represent the same amount of total utility. So this is going to be the one that's true. So we know this one's not true, but why is J providing a lower level of utility than H? Or why is that not true? Because J is on a higher indifference curve. It is representing a higher amount of total utility. Right? So the reverse of that would be true. Okay? So here we kind of got the one that's true. All the other ones aren't. Right? Now, if I had an example that looked like this, right? And I think this is similar to the one I showed you in the slides. But now we want to decompose this into the substitution and income effect. Okay. So if I move from my initial budget constraint to after the price change, so 1 to 3 is going to be like my total effect. So moving from this point to this point, this is my total effect. I bought the same amount of pizza, but I bought fewer cans of Pepsi. Okay. What would have caused my budget constraint to do this? It would have to be an increase in the price of this x-axis good or an increase in the price of Pepsi. So when the price of Pepsi goes up, what should the substitution effect be? So the substitution effect, usually we would look at where am I at in the same indifference curve, but facing different relative prices. I can actually do that not using the original one. I can actually do that on the new indifference curve as well. So we know that the new relative prices, the point where I'll get to this new lower indifference curve is 2, 3. The hypothetical budget constraint would be, okay, if I now could only afford this new level of total utility, but I was facing my old relative prices, so I've shut down the relative price change, I've shut down the substitution effect, movements along the same indifference curve, but different slopes, budget constraints, or different relative prices, A to this point would represent the substitution effect. So the substitution effect would be, I bought 1 fewer cans of Pepsi, 1 more can, or not one, I guess these are like half. So half a can of Pepsi and half a slice of pizza, right? That would represent my substitution effect. Now, what was my income effect? That was if I faced the same relative prices, but I'm on the new lower level of total utility. That reduction, I'm shutting down the substitution effect. Relative prices are the same, but I'm now kind of looking at this lower level of utility I can afford. So A to 4.3, that's my income effect. What? I bought 1.5-ish fewer cans of Pepsi, 0.5 fewer slices of pizza. That substitution income effect exactly like washed each other out for pizza, so it stayed exactly the same. And then both the substitution and income effect push quantity in the same direction, making that total effect a reduction of kind of 2, right? So moving from 4.3 to point A, I was keeping the relative prices or the slope of my budget constraint the same. So that was going to be shutting down the substitution effect. That represented my income effect. Moving from A to the point 2.3, I've now thought I can afford the same amount of total utility. I've shut down the income effect, but I'm looking at different sloped budget constraints or different relative prices. So A to 2.3 would represent my substitution effect. Okay, so we had what? Income and substitution. Okay. Oh, did I not select one up here? No, that should be it. Okay, so those should be kind of 2 answers for the quiz. We'll make sure there's, auto grades me. Yeah, we got all the points. Okay, so we got 2 minutes left. Probably doesn't give me enough time to really do the perfect substitutes, perfect complements justice. I'm going to post that Module 8 quiz. I don't believe there are any questions related to this on there. It's something that I thought if we had time, I'd cover. I will probably revisit this tomorrow just for the sake of the conversation. We'll kind of finish up this discussion about perfect complements or substitutes and how that relates to kind of our substitution and income effect. So you kind of will only be expected to know how to cover things up through this kind of Giffen good example. But then we'll finish this. So this will be stuff that's kind of viable for the exam. We'll then start Module 9. Should be able to finish Module 9 on Wednesday, and then we'll do a review on Thursday. So there's no other questions for me. I'm going to stop the recording here. Good.